Assalamualaikum, a very good day. My name is Nurhayati Abdul Halim from the College of Engineering, University Tan Sri Mara. Today I will be presenting our project on the developments of treated recycled palm oil based lubricant for minimum quantity lubricant machining application. This table shows the contents of this presentation, and I would like to start with a brief introduction on the scope of this project. In machining, MQL is one of the sustainable approaches to greatly reduce cutting fluid consumptions, where the lubricant is applied to reduce friction and heat at the tool chip and tool workpiece interface that inherently generated, and if not properly dissipated the heat, it will accumulate and elevate the cutting temperature and influence cutting performance with many bad effects. But most industrial lubricant pose risk to worker health and the environments. Bio-based lubricant, especially recycled ones, offer a promising alternative. However, different lubricants have different characteristics influencing machining performance. Thus, this study is about the developments of recycled treated palm oil as a cutting fluid alternative, where, as we know, palm oil is abundantly available in Malaysia, so we want to take advantage of it. Then, for analyzing and evaluating the TRPO effectiveness and performance, we conducted 4 ball tests in order to assess its tribological behavior in minimizing tool wear, reducing friction, and improving cutting efficiency. Developments of TRPO involve a series of filtering process, and we use palm kernel activated carbon to absorb any excess fat, neutralize the chemical, and eliminate the unpleasant smell. For characterization, the viscosity was measured where the test was conducted by using a viscometer Canon system as shown in figure 6, while figure 7 shows the cleaning process for the steel balls using chemical. Table 1 shows the parameters applied to conduct the 4-ball test, and table 2 is the properties of Coolloop 2210EP, where we applied also this commercially available lubricant for machining for the purpose of performance comparison. Along the test, the data of coefficient of friction and friction torque were measured immediately with respect of time, and the wear scar diameter was measured using microscope. Figure 10 shows the weakest machine that we use to measure micro hardness of the steel ball after the test. Okay, from viscosity analysis, our result demonstrate that the treatment process effectively reduced the viscosity of the used palm oil as compared to the before treatment conditions. However, it is still higher than the new palm oil and also the sunflower oil. While Coolloop exhibit the lowest viscosity, this lubricant is widely used by researchers and manufacturers in machining due to its superior lubrication properties. However, its high cost presents a significant limitations, particularly for industries seeking cost-effective alternative for their large-scale operations. For optimal lubrication effectiveness, cutting oil or lubricants with an appropriate viscosity is preferable, as excessively low and high viscosity oils tend to have negative impact on lubrication performance, especially in metal cutting processes. Therefore, identifying the optimal viscosity for MQL oil is crucial to maximize its lubrication effectiveness. Our investigation into the tribological properties of the RPO reveals some interesting findings. Initially, as shown in figure 12, the coefficient of frictions for TRPO was lower than new palm oil and also sunflower oil. This might be attributed to the presence of certain polar compounds in the recycled oil which can enhance its initial lubricity. However, as the experiment progressed, the coefficient of frictions of the RPO stabilized and remain consistent throughout the test durations, unlike the new palm oil and sunflower oil. This stable behavior could be due to the formations of robust tribofilm, a protective layer on the contacting surface which maintain a consistent friction behavior. In comparison, Coolloop exhibit the lowest coefficients through its enhanced lubricating properties. We also observe a strong correlation between friction torque and also the coefficient of frictions. where we found a consistent friction torque with respect of time. This stability suggests the formations of a persistent tribofilm which effectively maintain a constant resistance to rotation and also friction. Analyzing friction torque is crucial in tribology study as it provides information about dynamic friction behavior and energy losses within a system. In the context of metal cutting, lower and stable friction torque like that one observed with the RPO can translate to reduce energy consumption, lower cutting forces and improve to life. Okay, the wear scudder meter for the RPO as shown in figure 14 is higher than that of new palm oil, indicating slightly increased wear, while sunflower oil show the highest wear. Kulub, despite its lower viscosity, also resulted in a larger wear scale than the new palm oil, suggesting that other factors beyond viscosity might influence wear. For machining, a smaller wear scudder meter is generally preferred as it indicates less wear on the tool and also workpiece. In our study, we observed the new palm oil generated the highest micro-hardness alteration in the steel disc compared to other oils. On the other hand, the RPO, sunflower oil and kuluk showed comparable micro-hardness value, suggest that these oils were able to maintain a more consistent and effective lubrication films. So, in conclusion, our study found that treated recycled palm oil demonstrates significant potential as a sustainable lubricant for MQL machining. Its performance is comparable to the new palm oil and sunflower oil with stable friction behavior and good wear resistance, while Kuluk still demonstrates superior performance due to advanced formulation, but the RPO offers a more environmentally friendly alternative. We believe that with further research and optimization, the RPO can become a viable and sustainable solution for the future of machining. This is our main references. Thank you.